When we talk about designing a mining truck, the guide is not the payload, not productivity, but safety. At Austin Engineering, our philosophy is very clear. Safety first. A tray that compromises safety is not an innovation, it's a liability. Now, safety takes many forms. It starts with ensuring structural integrity. It continues with designing for predictable campaign life so that tray does not surprise the operator with failures. It extends to axle load splits, ensuring the truck brakes, steering, and suspension performed as the OEM intended. Payload optimization is, of course, critical, but payload cannot come at the expense of tire life, suspension reliability, and also on operator safety. Our job is to design trays that gives mines maximum productivity while staying within the safe operating conditions. Mine-specific conditions also define safety. A tray built for Pilbara iron ore will fail quickly in a South American copper mine if it has not been adapted. So altitude, temperature extremes, haul road designs, and fragmentation sizes, these are all the real-world conditions that determine whether the design will succeed. And finally, a tray must enhance the host asset, not just ride on it. The right tray improves mission stability, reduces spillage, lowers fuel consumption, and ultimately extends the life of the truck. So the decisive factors are clear: safety, payload, mine conditions, campaign life, structural integrity, and axle compliance. This is the foundation of Austin's design philosophy. Once we know these priorities, the next logical step is to define the design baseline, to create the DNA of the tray that everything else builds upon. Defining the design baseline. Defining the design baseline is like creating a blueprint for the tray's life. It's not just engineering data. It is the context in which the tray will exist. So we begin with the host mission details, its make, model, and capacity. Every OEM provides guidance on their axle split loads and the interface details. Next comes the site-specific accessories. Each accessories adds weight and changes how the tray performs, so they must be factored into the baseline. Then we move on to the commodity. Coal, iron ore, copper, and gold all demand different wear strategies. The density, fragmentation, and abrasiveness of the commodity define plate thickness, liner type, and discharge angles. A sticky coal mine tray will look nothing like an iron ore tray. We must also consider wear severity. How quickly does the commodity erode structural members? How much impact energy is delivered per load? These are all not trivial details that dictate the campaign life. And finally, dump and haul road conditions. A tray designed for flat, even haul roads will not survive in a mine with steep ramps and uneven benches. Clearance at the dump site, tipping geometry, and road width, all of this must be captured at the baseline. This baseline becomes the DNA of the design. Without it, an engineering work is guesswork. With it, the tray is built for success, and that's what we do here in Austin. But defining this baseline still isn't enough. We must go deeper into the heart of the problem, the commodity itself. Because ultimately, it's the commodity that shapes the design more than any other factor. Commodity is not just a cargo. It is the driver of every engineering decision, what we make here. Let me give you two contrasting examples. Coal is light, or any other ore. It's just light and a sticky material. It tends to cling on the tray walls, creating carrybacks. This reduces payload efficiency and forces additional fuel burn. We might be designing trays with smooth, flow-friendly surfaces and discharge geometries that prevent the hang-up. Whereas on the other side, there's ores, which is sitting on the other hand with dense and high abrasive properties. Every load grinds down the tray floor like a sandpaper. These applications demand thicker liners, replaceable wear plates, and material selections that balance the strength with weight. Moving on to the fragmentation, this also matters. So finer material flows like water, while blocky material impacts the floor like hammers. If the fragmentation is large, impact loading is severe, and the tray flow and welds must be reinforced accordingly. Discharge behavior is equally critical. Does the commodity flow cleanly out of the tray, or does it hang up, forcing operators to jerk the tray to clear the load? Poor discharge design is a safety hazard and a productivity loss. And then there is a dump clearance. Trays must be engineered to clear crushers, hoppers, and dump edges without material hang-up. If clearance is wrong, you get blockages, safety incidents, and downtime. So commodity defines everything: impact, wear, discharge, and carry back. Ignore commodity, you ignore the reality. Now let's think what happens when the commodity actually enters the tray. The shovel operator raises the bucket, swings across, and dumps the load. What forces are unleashed in that moment? That is what we will cover next. Loading forces are the true stress test of any tray. When a 70-ton bucket of rock drops from several meters above the floor, the impact energy is immense. That energy must be absorbed and distributed by the tray. If the design is weak, cracks form. If it is strong, the tray continues to perform. Fill factor is another important element. Pass matching ensures efficiency. If a shovel needs 6 passes to fill a tray, that could have been filled in 4 cycle times is wasted. Fuel burn increases and productivity drops. Tray size must be engineered to match the site's primary load too. Now, let's address the reality of overloading. It happens, and that is why we design in line with OEM policies. 10-10-20 overloading policy. The policy is not arbitrary. It protects operators, machines, and mines. The average payload must stay below the target payload. Up to 10% of the loads may go up to 110% of the target, but no single load may exceed 120%. Beyond that, you are outside safe design limits and you're compromising the truck's life and the operator's safety. We engineer our trays to handle this distribution. Critical load paths are reinforced. Welds are sequenced to minimize stress, so when an occasional overload occurs, the tray sustains it without catastrophic failures. We've talked more about the forces during the load. Now let's consider the bigger picture, the operating envelope, in which the tray must function. The operating envelope is everything that defines where and how the tray can safely work. It begins with machine interface, the frame mounts, hoist geometry, and even the suspension system of the truck needs to be considered. So these connections are non-negotiable. The interface, if the interface is wrong, nothing else matters. Dimensions are another constraint. Width, height, and depth must align with mine conditions. A tray that is too wide may not pass through site clearances. Too tall, it may exceed the height restrictions during transport and even during loading. Tip angles are also critical. If the tray does not tip far enough, material hang-up occurs. If it tips too far, it creates instability. Designing for the right tipping geometry is essential for safe discharge. Transport restrictions cannot be overlooked as well. Many trays must be shipped in modular form to meet road or sea freight limits. A design consider assembly on site, reducing risk and cost. And safety features that some clients request. Nose-tail interference prevention ensures the tray does not collide with the operator cabin. Canopy coverage itself is often specified for operator safety and shovel protection. Finally, the axle split compliance once again comes into the play. If the tray geometry causes too much weight to shift forward or backward, it overstresses the tires, suspensions, or brakes. OEM axle load splits must be respected. The operating envelope is not an afterthought. It is a boundary that ensures a tray is not just productive, but safe and legal to operate.
Thanks, Sekran. I guess just to summarize kind of everything that Sekran had touched on there, as a customized truck body builder, there's a lot that goes into the thought concept of putting together the right tray to allow you to hold more. I guess there's a balancing act for Austin as well between the end user and also the OEM. So as you heard from Sekran there, there's a lot of thought process that goes into making sure that we interface with the host machine correctly. And there's also a sign off with those OEMs where we've got a relationship and they sign off with body worksheets and the like to make sure that our customized equipment does in fact match and enhance the host machine. I guess the purpose of this slide here at the end of what Sekran has just spoken about is really understanding those operational parameters. So the machine is one side, but then the other side is, like Sekran mentioned, the loading equipment, the commodity, the site-driven decisions that allow us to go and design the right attachment to enhance your loading and hauling on site. I guess the main bullet point from this slide is if we understand what your operational challenges are and we have an open and engaged partnership, then 9 times out of 10, we're going to get it very right. And we're going to allow you as the end user to be able to maximize and enhance the productivity of your loading and hauling fleet. Now, the other side of that, there's always this kind of argument with productivity and payload is a payoff between reliability and longevity. In some cases, in really harsh mining environments where we're seeing that high abrasion rates, as Sekran had mentioned, then yeah, there's some considerations around wear maintenance strategies and being able to sweat that asset even further. But I guess if you look at what's in the middle of the diamond there, that total cost of ownership focus right from the start, understanding the customer wants to haul more, the customer wants to make more money, the customer wants to forget about their truck bodies and ensure that they are safely going to haul dirt for a set period of time. And I guess that's where we come in. And as the heading says, maximizing your productivity and also sweating your assets. So depending on the opportunity at hand, 9 times out of 10, we're able to do that both in giving a payload gain, but also in giving that life expectancy gain. And we have a predetermined kind of fatigue life that we run it through all our FEA and our engineering process here at Austin. And that really is about giving the customer before they make that purchase, because an asset like a tray can be a large purchase. At the end of the day, it's about really boiling that down and knowing what that total cost of ownership is upfront and ensuring that asset does achieve that, I guess, that design life by supporting that in the field. Back over to you, Sekran.
Thanks, Brad. So we've spoken more about the real actual mine site conditions and pros and cons of that. We need to talk about design considerations based on the real mining practices, what we follow here. Mining is not a control lab, as everyone knows. It's the harshest environment an engineered product can ever face. So this is why our design considerations go far beyond the CAD models. Structural integrity comes first. We use advanced FEA tools to identify the stress points, reinforce high load zones, and validate life predictions. Double-sided wells are used in critical areas, avoiding weak points that fail prematurely. Coming to the next point, material utilization is the next step. We just don't use thicker steel. We use the right steel. Q&T plates balance strength and weight. In some areas, lighter plates reduce dead weight. In others, hardened liners extend wear life. It's about precision, not excess. So plate configuration is equally important. Plates are laid out to distribute stress evenly, reduce sharp transitions, and make replacements easier. This lowers maintenance time and extends the structural life. And well joints, the unsung heroes of the tray performance. A single pour well can bring down the entire tray. We control the well sequencing to minimize the residual stress, and we design wells to flow with stress paths instead of against them. These are not small details. They are the difference between a tray that lasts 20,000 plus hours and the one that fails at 4,000 hours. But sometimes design innovation does more than just improve performance. I'll be talking more about the innovation a bit. I think Brad will be taking over the ranges, what we have in our portfolio. Over to you, Brad.
Yeah, thanks, Zekran. And I'll go through this slide fairly quickly. This is an educational piece, not a marketing brochure for Austin's truck body range. Otherwise, we'd be here all day. As you can see, we've got 6 design types on the screen. If I start from the far kind of left, is that Westech kind of square style of truck body that we started out with many moons ago. And they also have that square style of lighter Westech Premier body. So, really big, rigid, solid design bodies. The Premier is the lighter high performance version of the Westech body, which gives that payload benefit as well. From there, we're coming across the bottom of the screen to the JEC, and you can see the grey sections there. We've got the replaceable floor style of JEC body, very popular with customers in remote areas that, they want the benefits of a high performance body, but they want to make sure that the body goes life of asset as well, life of truck. So the JEC is a replaceable floor style truck body that allows the customer both of those stronger body designs with a replaceable floor. The JECLD was the first of the curved bodies here in the West Australian mining world, where we had a great run of and a long history of supplying JECLD bodies. Again, strength a little lighter than the JEC. And then from there, it advances around to the top of the screen with the Ultima and the HPT being the latest and greatest. So I guess the purpose of this slide is to say Austin have been doing this a long time. Depending on that partnership, understanding your operational challenges, we do have a truck body design that meets all of your requirements. We don't have one truck body design where we go thicker and thinner in the floor and that's what we put out to the market. We truly do sit down, have a listen and customize the truck body to suit what your operation is and how you want that asset to perform. One of those is around the floor design segment. So I think this might be your slide here.
Yep. Thanks, Brad. Yeah, the flow control body is a story of engineering born from necessity. I think a few years ago, a customer approached us with a problem. The truck had short wheelbases, and when they dumped material, the entire load center of gravity shifted behind the rear axle, lifting the front wheel off the ground. It's a serious safety hazard. Everybody knows that. So our engineers developed a solution by designing angle flows. We ensured the CG stayed forward during discharge, and we even built a scale model to validate the dumping sequence before manufacturing the first body. The result was a patented flow control design. What did we achieve? What did that innovation achieve? It eliminates the material surge during dumping so that the truck does not jerk violently, keeps the front wheel safely onto the ground, reduces the dust emissions, and improves crusher efficiency, extends lift cylinder life, and protects the tray itself. In short, it turned a safety hazard into a competitive advantage. Hundreds of flow control bodies are now in operations across the world. That is the power of engineering innovation, responding directly to the customer challenges. Moving on, I think beyond these kind of flagship innovations, we also focus on a practical solution that keep our trays tougher and easier to maintain. I think this slide talks more about that. Every mine is unique, and our solutions reflect that. The wear management is just not a one-size-fits-all package. We use wear strips and towels in high abrasion zones, targeting the exact areas where the material erosion is most severe. In the middle, you can see the replaceable flow, another innovation. Instead of discarding the entire tray when the flow wears out, we retain the skeletal structures and replace only the worn plates. And of course, this reduces the cost and downtime dramatically. Finally, the tail replacement, it offers the same benefit. Rather than rebuilding the whole tray, we can swap the rear segment quickly. This gets the truck back into operation faster. These are the approaches shows why we say our trays are tough as your job, because they are being built not just to survive mining, but to thrive in it.